page. Let's say we have cosine v over secant v sine v. And we want that, this time we're going to try to prove that one side equals another side. And let's say we want that to equal to cosecant v minus sine v. Well, if we take the left side and we say cosine v over, and we change secant to its reciprocal identity 1 over cosine v, and then times sine v, we get cosine v over sine v over cosine v. And if we take our denominator and flip it, we can get cosine v times cosine v over sine v. So we took the denominator and multiplied the reciprocal to that. And so now we get cosine squared v over sine v. Now we want it to be, we want cosecant v and sine v. But if we were to look at the second to the last step to this, cosecant is the reciprocal of sine. So that's 1 over sine v minus sine v. So we need just all sines basically, right? So that means if we took cosine squared and changed it in terms of sine, we know that cosine squared is equal to 1 minus sine squared. So we make this 1 minus sine squared v over sine v. Now if we split it, 1 over sine v minus sine squared v over sine v, and we know that the sine and the sine squared can cancel, right? And here we go, we're at our second to the last step. 1 over sine is cosecant. So that makes it cosecant v minus sine v, and we have an equivalent to the right hand side, and that's what we wanted. Okay, and you have to look at this whole thing as the answer, not just individual steps. So you have to prove every step. Why did something go from one step to the next? So you have to complete it all the way to the very last step. You can't stop second to the last step, you have to go all the way to the last step. Okay, that's lesson 15. Now let's take a look at lesson 16. And that's continuation of 7.1. And this is more trig identities. And if we had cosine squared x minus sine squared x equals to 2 cosine squared x minus 1. Well, notice that we want to prove one side or the other. took the left side, and if somehow we could just have all cosine, maybe we could get it to look like the right side. So what we can do here is take sine and change it in terms of cosine. So here we have cosine squared x, that's not going to change any, minus, and then we put in parentheses, we change sine squared in terms of 1 minus cosine squared x. And then we go ahead and distribute that negative, right? So that'll make a plus, that'll be a minus, and a plus. So now what we have here is cosine squared and cosine squared is 2. Cosine squared x minus 1, and that equals to the right hand side. So all these different steps I'm showing you, these are methods that you can use to solve other types of problems that are similar. So it helps to try to remember how we did certain problems as we go through these. And that's all we're going to do for lesson 16. Now lesson 17, that's even more trig identities. Basically, it's just a continuation of what we've been doing. So let's say that we have a problem such as cosecant squared x minus cotangent squared x over secant squared x. And we want that to be equivalent to cosine squared x. But you always want to try to take the more complex side and simplify it down to the simpler side. So this time we're going to take the left side and try and break that down. Well, we said before, anytime you see cosecant and cotangent, or secant squared and tangent squared, you want to see if that applies to a trig identity. Well, we know that before that cotangent, we said before that cotangent squared, and actually let's go back another page. We said that, remember when we showed our trig identities for secant squared minus tangent squared is 1, and cosecant squared theta plus cotangent minus cotangent squared theta is 1. Well, that's what we're using here. We know that cosecant squared minus cotangent squared is 1 over secant squared x. And 1 over secant is the reciprocal of cosine. So that just brings us right to cosine squared x, and that equals to our right hand side. So we didn't have to break this down in terms of sine and cosine. But, you know, if you get stuck, you could do that. It would be longer to put all this in terms of sine and cosine and then work it from there. But if you could try to avoid that, it would be, sometimes it's a lot easier to try to just work with the